Hey guys, how's it going? Welcome back. So today we're going to talk about completing the square for the SAT math section because it comes up twice on the test. First, you'll see it on parabola/quadratic equation problems, and then you'll also see it for circle equation problems as well. So what I'm going to do today is I'm going to give you some context as to why we're even doing this in the first place, and then walk you through a method that I hope you find a little bit easier to do than what you may have learned from school. So let's get started. Let's talk about the quadratic equation first. You have the equation ax squared plus bx plus c is equal to 0, where a, b, and c are constants, meaning they're numbers that just never change, like 5, 7, 8, etc. For this lesson, we're going to assume that a is equal to 1. So then your equation just simplifies to x squared plus bx plus c is equal to 0. Let me give you a real equation. So what if I said x squared plus 8x plus 16 is equal to 0. If you notice, this equation is actually easy to factor. So you have basically x plus 4 times x plus 4 is equal to 0, which is equals x plus 4 squared is equal to 0. What happens if you have a quadratic equation that you can't factor? For example, if you have x squared plus 8x plus 17 is equal to 0. This looks like the one that we just had before, except that you can't factor out the 17. What you do next actually depends on what the question is asking you to find. When we use completing the square for a quadratic equation, you're using it to put the parabola in what we call the vertex form. So the vertex form basically tells you where the vertex of the parabola is, meaning like you can basically tell how the parabola shifted horizontally and vertically. So let's go ahead and complete the square for this quadratic equation. The first thing you're going to do is you're going to move the constant to the left side, not because there's anything special, it's just because we don't need to deal with it right now. So in this case, you move the 17 over to the left, and then we have x squared plus 8x is equal to negative 17. Because it's called completing the square, I'm going to set up the next part as if we're squaring something and set that equal to negative 17. So for example, we have something plus something squared is equal to negative 17. The next thing you're going to do is you're going to move the x down for the first term, not x squared, but just x. So we have x right there. And then for the second term, what you're going to do is you're going to take the 8 and you're going to divide it by 2. So 8 divided by 2 is 4. And that's your second term right there. So 8 is technically b, so we have b over 2. The next thing you're going to do is you're going to take 4 and you're going to square it. So 4 squared is 16, and then you're going to add 16 to the other side. The reason why we added 16 to the other side is because you made up a fake number, and that fake number was 16, which is from the left side, in order to make the left side look really nice and neat. So if you don't know already, basically if you have a number on both sides of an equation, the number will cancel out. So for example, here the 4's cancel out. Going back to the problem, we now have x plus 4 squared is equal to negative 1. Bring the 1 to the other side by adding it. So now we have x plus 4 squared plus 1, and just set this equal to y. And this is your vertex form of your parabola. I'm going to just flip the equation so it's easier to read. So we have y is equal to x plus 4 squared plus 1. And then if you know anything about your parabolas and vertex form, this basically tells you that you have a horizontal shift to the left by 4 units and then a vertical shift up by 1 unit. Okay, so let's apply completing the square for the circle equations. If you don't know the circle equation, it's x minus h squared plus y minus k squared is equal to r squared, where h and k are coordinates of your center of your circle, and r squared is equal to your radius squared. Okay, so on the SAT, they basically ask you to find the center or the radius for a circle, but it's not going to look like this equation or else it'd be too easy. What they're going to do instead is basically give you an equation where it's all jumbled up like this, and then ask you to find the center and the radius. The problem is you can't just take this equation and make it look like this automatically. What you have to do is actually complete the square. So what I would do next is move your constant to the right side because we're not going to deal with it, and then compartmentalize your variables, like put all the x's next to each other and put all your y's next to each other. So in this case, it would be x squared plus 4x plus y squared plus 6y is equal to -2. Okay. So the next part is where students often make a mistake where they try to separate the equation into two equations and then try to complete the square for all the x's and all the y's. Don't do that. So basically just complete the square for everything side by side. So let's just put like a vertical line right here just to organize it a little bit. And then remember, it's something squared for both the x's and the y's. And then this is equal to -2. Okay, so let's complete the square for the x first. Remember that you bring the x down and then you take this 4 and divide it by 2. So 4 divided by 2 is just 2. And then you have to compensate and put the fake number on the right side. So in this case, it's going to be 2 squared, which is 4. So let's add 4 to the right side. And that's it for the x. Let's complete the square for the y. So again, in this case, bring y down for the first term. Take the 6 divided by 2. 6 divided by 2 is 3. So that's the second term. And then 3 squared is your fake number, right? So it's 3 squared. 3 squared is 9. Add that to the other side. And then let's clean this up a little bit. So now we have x plus 2 squared plus y plus 3 squared is equal to 11. So now this is your circle equation where your center is at -2, -3. And your radius, remember that this is r squared, not r. So your radius is actually equal to square root of 11. Okay, so try this circle problem on your own. Okay, so let's review. So the first thing you would do is move the constant to the right and then arrange the x's and the y's separately, right? So we're going to have x squared plus x plus y squared plus 3y is just equal to 1. And then again, you're going to complete the square for both the x's and the y's separately. So let's just set it up like that for right now. And then let's start with the x. So we have x here. The coefficient in front of this x is actually just 1. 1 over 2 is just 1 over 2. So we have 1 over 2 for the second term. And then you square it. So 1 over 2 squared is 1 over 4. And let's add that to the other side. And then that's all we have to do for x. And let's do y now. So again, bring the y down. The coefficient in front of 3y is just 3, so let's divide that by 2. So 3 over 2 is just 3 over 2. Square it. So 3 over 2 squared is 9 over 4. So the left side is pretty straightforward. You have x plus 1 over 2 squared plus y plus 3 over 2 squared. And then the right side, basically, you just need to find a common denominator, which is 4. So multiply 1 by 4 over 4. And then we have plus 1 over 4 plus 9 over 4. So then you end up getting 4 plus 1 plus 9 for the numerator, which is just going to be 14. So now we have 14 over 4 on the right side, and the left side is still the same. So now you can say that your center is -1 over 2 comma, -3/2. And that your radius, remember that this is again r squared, not r. So your radius is going to equal the square root of 14/4. If you wanted to simplify this, this would be square root of 14/2. And that's it. So I hope you found this helpful. Feel free to leave a comment below, and I'll see you next time.